Hello, this is Mr. Stansbury. I'm going to take you through some of the problems on the 14F assignment. Okay, we're going to start here with number 2. A coin is tossed 10 times, and X is the number of heads which will occur. Find the mean and variance of X. Okay, so mean is this here, which is mu, equals the number of trials, which is 10, times the probability of success. Okay, so heads, the probability of getting heads is 0.5. So 10 times 0.5 is going to equal 5. So the mean for number 2 is going to be 5. Okay, and then now to find the our standard deviation. Actually, it just says the variance. Okay, but so I guess we'll just do the variance, and then later we'll do the standard deviation. That's a little bit better here. So anyway, variance is this little O with the cape on it. I call it super O because it's O with a little cape there. Okay, and we get that squared equals n times p, which we just figured out was 5, times 1 minus our probability, and the probability is 0.5, so that's going to be 5 times 0.5, which means that our variance is going to be 2.5. Okay? Okay. Number 4, a city restaurant knows that 13% of reservations are not honored, which means the group does not arrive. Suppose the restaurant receives 30 reservations. Let the random variable x be the number of groups that do not arrive. So that's our 13% that don't arrive. Find the mean and standard deviation of x. So our mean is going to equal the number of trials, so that's 30, times the probability of success, which in this case is going to not be honored, so that's times 0.13. Okay, so 30 times 0.13 gives us 3.9. Okay, so that is the mean or the average. Okay, so now we want to find the standard deviation. So our standard deviation here is going to be the square root of n times p, which is our mean, which we know is 3.9. And then we're going to multiply that by 1 minus the probability, so 1 minus 0.13. And we're going to take the square root of that whole thing. So let's do this. Second square root, we can just do this whole thing all at once. 3.9 times 1 minus 0.13. Push enter, and we get 1.84. Okay, so our standard deviation is about 1.84. Okay. Okay. Last one we're going to take a look at here is number 5. A new drug has a 75% probability of curing a patient within 1 week. Suppose 38 patients are treated using this drug. Let X be the number of patients who are cured within a week. So 75% chance of curing. So curing is our goal here. All right, so find the mean and standard deviation of X. So our mean is going to be our number of trials times the probability. Okay, so there's 38 times 0.75 chances of success, right? So our mean in this case here is going to be 38 times 0.75, which gives us 28.5. That's our mean. And then our standard deviation is going to be the square root of our mean, 28.5, times 1 minus our chance of success, which is 0.75. Okay, so we could just put that all in the calculator just like it looks. 28.5 times 1 minus 0.75. And that gives us 2.67. Okay. So, and just so you remember, like the standard deviation is basically like on average how far away, like you choose like, you know, like a random one of your patients here. On average, they'll be 2.67 away from the mean, which is 28.5. Okay, so that's 28.5 of the patients. So, sorry. When you do a full set of trials of the 38 trials, on average, you'll be either 2.67 above that or 2.67 below that. That's what the standard deviation means. Okay, so that was A. Part B is find the probability, and now they got all this crazy notation here. The standard deviation minus, the mean minus the standard deviation for X, and then the mean plus the standard deviation. So this is saying find the probability that X is going to be between one standard deviation below and one standard deviation above. Okay, so we're going to end up using this the calculator here to figure out this one here. So the mean minus the standard deviation, so that's going to be 28.5. Sorry, I'm not sure why that's not showing up. Minus 2.67. And then 28.5 plus 2.67. So when we do that, 28.5 minus 2.67, that gives us 25.83. That's less than X, which is less than, and then we do 28.5 plus 2.67. So our high is going to be 31.17. Okay, so what we want to do is we want to figure out what's the probability that you're going to have fewer than 31.17. So, so really we're just going to put this number straight in. Okay, so what we'll do is we'll just figure out the probabilities of both of those. Okay, so we're going to do second variables distribution go down to, these are both going to be CDFs, binomial CDFs, because you don't want to find the probability of it hitting the exact number. It's between a range. So CDF. So there's 38 trials. I went through and did some of these already. Probability of success is 0.75, and we want to know probability of being 25.83. Okay, so all the way up to that is 0.132. So it's 0.1. Oops. Look, I already have our numbers on here. There we go. Oops. I really should erase that. I was doing this ahead of time to make sure I did it right for you guys. There we go. So, probability of it being less than, fewer than 25.83 is 0.132. So we got 0.132. So 13.2%, that'll be less than that. But we actually want to know what the chances of it being between these two. So then we go back in here, second variables, binomial CDF, and then 38 trials, 0.75% of success, and then we'll do 31.17. So the chances of getting 31.17 or any number less than that is going to be 0.872, we'll call it. right? And then the probability of it being less than 25.83 is 0.132, so we're going to simply subtract these two. So we'll take 0.872 minus 0.132, and we get 0.740. So there's a 74% chance that it's going to be within one standard deviation of the mean. Okay, that's a pretty tricky one here. I would, if you expect to see this, this would probably be an extra credit type question come test time. That takes a little bit of work, but it's doable. It's just relating what we learned in the last section. Okay. All right, that's all we have for the 14F assignment. If you have any further questions, please feel free to ask. Thanks.